Welcome to a new week number 12, the flow of charge.
And the topic for today is electrical components. Okay. So here we'll watch a video that tells us about static electricity. And basically, it tells us about the electrostatic force, which means that within any two electric particle, there is a force. And that force depends upon a relationship, which is Q1, Q2 multiplied divided by the radius squared. Okay. So even though that is a little complex and beyond the scope of P6, just understand that all electrons or electric particles have an attraction force called electrostatic force. Okay.
One of the really simple experiments we do when we teach E&M is to demonstrate Coulomb's law and the interaction between charged particles using Scotch tape, using just sticky tape put on the table. When you peel it off, it acquires some charge. Since I'm doing a blog post about this, I thought it might be a good idea to have a little video that shows exactly what happens in these situations so you can see the physics I'm talking about. So the idea is you just take a piece of tape, peel it off the table, and when you do that, it picks up some charge. You can tell it has picked up some charge because it's attracted to my hand once I do that, and that's a polarization force from the charged tape to my neutral hand. If I take a second piece of tape prepared the same way, these two should repel each other. And you can see that the tape bends apart like that until it gets so far apart that it starts to stick to my arm. What's more interesting, and the subject of the blog post, is to take two pieces of tape and arrange for these to be so that these are neutral. Right? This isn't attracted to my hand significantly. Then when I separate these two tapes, one of them is going to end up positively charged, the other is going to end up negatively charged, and these should attract each other. Stop sticking to my hand. These should attract each other, unlike the other ones that were pulled apart. The interesting thing about this is it's really hard to get these tapes in a place where you can see that they're attracting each other, but not have them come all the way together and collide. And that's an interesting phenomenon that turns out to be kind of hard to model mathematically, and that is the subject of the blog post that you'll have to go to Uncertain Principles and take a look at to see how that turns out.
The purpose, today we will learn about electric components to be able to access internet to specify components and characteristics of each component of simple electric circuit from visible evidences. We will draw triangles with side length and side sizes when they have been specified, and search for and collect the terms related to other learning areas from learning sources and present them through speaking and writing.
So let's go to the vocabulary. So number one, electricity. Electricity. It's all what is you see around your house, everywhere you see light, electricity with charging your phone. It's the material charge.
Okay. The second is a component. So every single piece that makes up something bigger is known as a component. So in your laptop, you have the keyboard, and the alphabet A is a component. The enter key is a component. The spacebar is a component. The webcam is a component.
Okay, number three, symbol. Symbol. So in electricity, to draw, we need to have symbol to describe something. So can use a symbol about a logo, but here the symbols to describe a wire, a bulb, or resistors.
Number four is circuit. Circuit. So anything that completes a full circle is known as a circuit. Okay. So when you have the racing track and the car completes one full lap, that is a circuit. Over here, it means an electrical circuit. So when you have a closed diagram from the battery to the bulb and back to the battery, that entire arrangement is called a circuit.
Okay, and the last one, the resistor. The resistor. That is to block the electricity on a certain point.
Okay, so here we have the circuit symbol. As you can see, we have the battery, and then the battery has a positive charge, and it has a negative charge as well. And so there you see the electricity starts from the positive, and it flows to the negative, and along the way it lights up the bulb. In this case, the bulb is a resistor. Okay, so you can see the symbol, the cross symbol, that is the resistor symbol for the bulb. So if you replace it with a fan, or if you replace it with another electric lamp or a charging station, all of them are resistors. Okay, and you can see the symbol of the battery on the top as well. So here we have a circuits diagram for another circuit, and in the first one we had only one bulb, but in this case we got two bulbs, and they are connected in parallel with each other.
Okay, so here electric current is a flow of charged particles in a circuit. In a wire, this will be a flow of electrons. So we need two things for an electric current to flow. One, something to transfer energy to electrons, such as a battery or power pack, and then a complete path of the electrons to flow through an electricity circuit. So you have here the battery, and here it's flowing, bulb, here a switch to turn off, turn off. So you see if it's open, then the bulb turns off. Electric current is the movement and direction of electricity in a circuit.
Okay, and one little thing, can we just go back, teacher? I'd just like to point out something. So the electron flows from negative to positive. Okay, so in this diagram, you can see that from the negative to the positive, the electron is flowing, but the current actually is in the opposite direction. So the current will flow from the positive to the negative. Okay, so the electron is negative to positive.
So here, a few examples of the symbols. And then the second one, it's a Kung Fu symbol exercise. So then you can watch the video and do at the same time the Kung Fu type.
We're going to look at circuit symbols. Now this video is all about memorizing. You have to be able to look at a symbol and tell me the name of it, and you have to be able to look at the name and be able to draw me a symbol. If you'll be able to do all of these very quickly, so take some time to learn these off by heart, then the later stuff, which is more difficult, will seem so much easier to you. This is a cell. Most people think they have two batteries in their remote control at home, but actually they have two cells. Now cells are used to give energy to the electrons in the circuit. So when the electrons pass through the cell, they gain energy, and that allows them to flow around the circuit. Now there are two parts. The left hand side is short and fat. This is the negative side of the cell. And the other side is long and thin, and that's the positive side of the cell. This is a battery, and a battery also gives energy to the electrons in a circuit. Now because you've got two next to each other, the voltage is actually doubled. Batteries can be quite tricky. They need to be placed this way round. So the top picture here shows it goes negative, positive, negative, positive. It must go that way round. Another way to write it is to use a little dotted line in between, just like the middle picture here. What you mustn't do is draw a line all the way in between, like the bottom picture, because that short circuits it and you won't get any current flowing at all. I recommend using the top one so you have no gaps or no lines between the two cells. This is a wire. Wires carry current around the circuit, and they must be straight, and you must use a pencil and a ruler. This is a switch. A switch allows part of the circuit to be disconnected. Everyone knows what a switch is for. Lamp or bulb. This gives off light when electricity passes through it. You may be able to work out from the other videos that as energy goes through the light bulb, the energy is taken from the electron and given to the light bulb, and the energy is transferred into light. Here's a resistor. Resistors restrict the flow of current. A variable resistor, very similar to a resistor, but you can change the resistance, therefore you can change the current flowing through a circuit. It's the rectangle with an arrow through it. This is an ammeter. An ammeter measures the current in a circuit. It must be placed in series. We'll look at how to connect ammeters in the next video. A voltmeter is used to measure potential difference across a component. In the next video, we'll also look at how to connect a voltmeter in parallel. This is a thermistor. Thermistors are very interesting, and they're used a lot in this exam. As the temperature increases, the resistance will decrease. LDRs are also important. They stand for light dependent resistor, and they're very similar to thermistors in a way, but as the light intensity increases, then the resistance will decrease. This is also a really important symbol to learn for this exam. Motors transfer electrical energy into kinetic. So they turn your electrical energy in your wires into something useful that moves.
This is Mr. Capra from Samuel Ward. We are here in Mozambique on the Samuel Ward expedition, and we thought we'd give you a treat of our learning the electricity symbols Kung Fu style. First of all, we've got to thank the gods of electricity. Electricity. So here we go. First one up. Cell. 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 Number 2. Battery. 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 Number 3. Resistor. 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 Number 4. Variable resistor. Resistor. Variable. Resistor. Variable. Number 5. Thermistor. 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 LDR. Resistor. LDR. Resistor. LDR. Ammeter. 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 Then the voltmeter. 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 Lump. Lump. And lastly, but not least, the diode. 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 Electricity. 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 So this is for you at YouTube, so you can use in your lessons. And this is Mr. Capra, and I'll see you later. Welcome back to the video. Here's some description.
There's some vocabulary here. So the wire connects components and passes current easily from one part of the circuit to another.
Then the cell supplies electrical energy. The larger line is positive, plus. A single cell is often called a battery.
And a battery is, when you have a single component, it is called a cell. And when you have more cells lined up together, you call it a battery. And again, the larger line is positive.
then the fuse, a safety device which will blow or melt if the current flowing through it exceeds a specified value.
Okay, so the fuse is very important. Let's just say if there is no fuse and the electric current shoots up and you connect it to your laptop, it can damage your motherboard. Okay? So that is why you have the fuse, and if the electricity goes above that value, then the fuse will melt and the circuit will open. And then we have the lamp or a bulb, and so this symbol is used for a lamp, which is an indicator. So that is the cross symbol that we showed you in the previous diagram.
And the last one, the resistor. So the resistor restricts the flow of charge. Use include limiting the current passing through an LED. So without this, you can have overcharging. Okay, here you have the symbols. You watched the video before, so try to find the name of the symbols. So pause the video and make the exercise, and we'll give you the answer very soon. Okay, so the number one, the switch, open.
So number two is the closed switch. So when the switch is closed, the electrons start flowing, so the current also starts flowing.
Then you have the cell, only with one side.
And here we have a combination of cells. So this is your battery.
This one you should know, the lamp or bulb.
And here we have the protection mechanism, so that is the fuse.
So the work mode, draw all of the electrical device in the classroom. Things to include light bulbs, switches, plug socket, fans, air conditioner.
So now since you're at home, you can actually draw a circuit diagram for your home, okay? So just take a look around you, see where the switch is, see where the lamp is, see where the bulbs, the tube light, the fans are, and then try to draw a diagram that connects the switch to the fans, okay? And in your home and everywhere else, the power comes from the main CRPAO organization, so it comes from the government, so you don't have a battery. So just don't worry about that, just draw a normal battery and draw a closed circuit system for your house.
So you will be like an architect and draw everything by your own.
Okay, here we have some mathematics for you, so some geometry, and we would like you to practice drawing a few triangles, okay? And every triangle has 3 angles inside them, and you can measure the angle using a device called a protractor. So just watch this video on how to use a protractor as well, and draw 5 triangles.
Hello everyone. Thank you again for joining me on this problem where we are going to get a little bit more practice and experience with measuring angles using a protractor.
Cool.
So here we want to know what is the measure of angle MLN. So the first thing that we want to do is identify that specific angle on the diagram. So we see angle MLN is formed by the points M, L, and N, with the vertex at point L. So without any numbers or angle measurements given to us on the diagram, we need to ask the question, how can we measure an angle? Now in our geometry toolbox, we have a protractor, which are commonly used by students as ninja throwing stars, but they can actually also be used to find angle measurements. Don't be that student. Please don't be that student. Okay, so this is how it works. We take our protractor and we see that it has that center marker, and we are going to align it with the point that is the vertex of the angle that we want to measure, in this case, point L. So again, we align that center marker with the vertex point, and we also want the flat horizontal portion of the protractor perfectly aligned with the bottom line, okay, our bottom ray that makes up our angle. So now we can use the top ray, in this case the line that starts at point L and goes through point M, and see what measurement it is aligned with on the protractor. So the protractor shows us that angle MLN has a measure of 60 degrees. So our conclusion is that angle MLN is 60 degrees, and we are finished with this question. So this is a little bit more practice helping you to understand how to use a protractor to find the measure of a given angle. And that's really all there is to it. So I will catch you guys next time. Thank you again for stopping by. You guys are the best. Have a good one.
Okay, welcome back, and we arrive to the thinking tool. So draw the symbols and write a description of each item. And here the example for the wire. Wire connects components and passes current easily from one part of a circuit to another.
Okay, and here we have the switch, but we haven't given the details. So look back in the video, look back at the YouTube videos. We gave you a vocabulary sheet with a lot of information. So try to take notes from there and finish this thinking tool. Okay.
Try at least 4 more symbols.
So in total 6. Okay. So just to give you a hint: wire, switch, cell, battery, resistor, lamp, fuse. Okay. All those you need to write them down.
Okay. So why do we use symbols when drawing electrical circuits?
Think about it. I mean, why can you not draw the fan? Why can you not draw the lamp? Why can you not draw the switch? Why do we use the symbol? Okay. So think about that, and finish your thinking tools. Just a reflective part. So the thinking tool is a diagram using triangles of electrical symbols on an A4 size paper.
And don't forget to write the meaning in English and in Thai. Okay, see
See you next time. Bye.